In this segment, we're going to talk about the distance scales we use in astronomy. The first distance scale we'll go over is the astronomical unit, or AU for short. An astronomical unit is the average distance from the Earth to the Sun. 1 astronomical unit is equal to 1.5 times 10 to the 8th kilometers. Or it is 93 times 10 to the 6th miles. Since 10 to the 6th is million, that's the same thing as 93 million miles. As shown in this cartoon, the average distance between the Sun and the Earth is 1 astronomical unit. We say average because as the Earth goes around the Sun in its orbit, it's not exactly 1 AU the entire orbit. But on average, the average distance is 1 astronomical unit. Now notice in this image, on the right, you can see that the Earth is tiny compared to the size of the Sun. And if you look at the bigger image, the Earth is tiny compared to the size of the Sun, although not drawn to scale. And the AU distance is very large compared to the size of either the Earth or the Sun. You would use astronomical units to describe the distances within the solar system between objects, such as Venus and Jupiter. Or you would use astronomical units to describe the size of objects. Usually you express the astronomical unit as a distance scale between objects in the solar system. Another unit we use in astronomy is called a light year, or LY for short. A light year is the distance light travels in 1 year. The key word here is distance. Even though you may see year in the word, light year, it is not a time unit, it is a distance unit. It is how far light travels in 1 year. As shown in this artist's conception, or drawing, what we are looking at is the Milky Way galaxy. And as shown in the cartoon, here is the location of the Sun and the planets and the asteroids and the comets, and notice how far away it is from the center of the Milky Way galaxy. That distance is 53333 light years, or about 53,000 light years. The full diameter of the Milky Way galaxy is 80,000 light years. And so where the Sun is located and all the planets and comets and asteroids, it's about 53,333 light years from the center of the Milky Way galaxy. So the light that you see here in the center of the Milky Way galaxy takes 53,333 years to reach us at Earth. So at night, when you look up in the sky and you can see that milky, white, hazy glow in the sky called the Milky Way, that light you're looking at left the center, or that lights from the stars in the center of the galaxy about 53,000 years ago. And so you're looking at light that happened long ago and is just reaching your eyes now. And the distance that light took to travel was 53,333 light years. Notice how tiny the Earth is and the Sun and the solar system compared to the size of the Milky Way galaxy. The next unit we're going to look at is a parsec. A parsec is a very long or very large unit. 1 parsec is equal to 2.06 times 10 to the 5th AU, or about 0.2 million AU. It is a very, very large unit. A parsec is also equal to 3.26 light years. So light would need to have to travel 3.26 years to reach the distance of a parsec. So if we look at this as the length of a parsec, then this is the equivalent length of a light year. So it's much shorter than a parsec. And if I were to compare an astronomical unit, it would be less than the width of that red line. So 1 astronomical unit is very, very small. and you would use it to measure distances within the solar system. A light year is a much, much longer unit, and you would use it to measure distances to nearby stars. A parsec is a very, very large unit, and you would use it to measure distances to faraway stars, all in the Milky Way galaxy.